Hello everyone, welcome to my new video. So today I'm going to solve this new question on linked list, delete the middle node of a linked list. So here's the problem statement. You are given the head of the linked list. You have to delete the middle node and you have to return the head of the modified linked list. So middle node of a linked list of size n is basically then by two nodes from the start using the zero-based indexing, where this donates the largest integer less than or equal to x. So here is all the example test cases. Let's just dive right into the whiteboard and see how we can approach this problem. Let's just copy this first. This is the different example case. Yeah. So this is the linked list 1, 3, 4, 7, 1, 2, 6. Okay. So here, what we have to do is basically we have to delete the middle node. So if we have a look on this linked list, the length of this linked list seems to be 7. So the middle node is going to be this. So we have to delete this node and we have to return the new modified linked list in our output. So how are we going to do that? Uh, let's say we have a head pointer which will point at the very first element, head pointer, and also the temp pointer. So we'll also keep a temporary pointer just to make sure we are traversing that pointer to keep track of where our iterator is currently. So this is the temp pointer, and temp pointer will also be on the very first element of the linked list as of now. So first of all, what we need to do, we will have to find the length of the linked list in our code. So how are we going to find that? So there will be just a basic while loop. We will just create this while temp. So while temp, so until the end of linked list, keep just incrementing the length variable. We can just define that. This is just a pseudo code, so uh, don't mind any syntax errors or anything like that. So length plus plus, and we'll keep traversing it until we reach the end. So with this particular with this line of code, we'll get the length of linked list. So now, as we have the length of linked list, we will have to find the middle node of the linked list. So how are we going to get the middle node? It's just simple. We can just keep it something like node equals to length by 2. So with this, we have the middle node now. So how we can delete this pointer 7? So we will have to traverse the loop one more time, and we'll have to make sure that we will stop right before the middle element. So here we'll have to stop at 4 in this case. Let me explain what I'm exactly meant by that. Int equals to 0. We'll iterate the loop until the previous element of that middle node, and then do this I plus plus. So now our temp variable, we are moving our temp variable from first element to right before that middle element. So it is going to be here now at 4. So this is our temp variable. As of now, we have temp here. We have temp here. So now, let me just write temp is equal to temp. Okay. So everything looks fine as of now. So now in this loop, temps. So if we will go even one more element further, we are going to find the middle element. But we do not want to keep that in our linked list, right? So we will have to skip that element. So how we can skip that element? We can basically store that next element in a uh, new variable. Let's say node star to delete. Let's just keep it to delete. So we can store our temp the to delete temporary to delete variable as a temp.next. So in this way, the 7. So now 7 is stored as to delete. So we'll have a look here. It is the to delete now. Okay. So to delete variable is this. So we can just simply write delete to delete this variable. And now we'll have to make sure that our chain keeps on moving continuously, even after skipping one element. So how we can do that? we can just do it with this line of code. We can say temp next is equal to temp next next. So, so with this particular line of code, we'll be able to skip that element and we will jump right into the next element and we can return that linked list that we actually want to return as the to delete element is already deleted, the middle node is already gone now. So this was just the pseudocode of and just the approach how this is going to work. Let's just go into the source code and see if the solution works or not. So here we have, it's just so what LeetCode does is that it will create you a struct where you'll have an idea what to use for the next variable and all that. So basically, it's every time it's same. So you can have a look on that. So very first thing what you'll have to do, very first thing, you'll have to make sure that the linked list is not linked list is not empty, or even if it is there, if there is a only one element in the linked list, we are going to return null pointer because there's no point in even finding any middle element if it's just one element. So if star not head or head next, we will just delete the head and we can return the null pointer. So this is the if statement, which is basically the termination condition, which we will just write it in the beginning. So now what is our next step? Next step is to find the length of linked list. So we'll go here, length is equals to 0. Int length is equals to 0, and we will have to define one more variable called temp, as we discussed. This is going to be like this. It is going to be point directly to the head. Then we can create this loop to make sure we are counting the length of linked list correctly. Uh, yeah, so get to temp is equal to temp next. And first of all, we'll have to increment the length count. Yeah. So now we have the length of the element. So now we need to find the node that is going to be length by 2. Okay, length by 2. And then we have to make sure that we are keeping the temp and head both at the same position just to make sure we are keeping track of all the locations. Uh, so now we need to run one more loop from here. Int I equals to 0, I middle node minus 1, I plus plus. Now we can do the temp is equal to temp next. And then this node star to delete, we can just define one more variable here. So star to delete is equal to temp next. And then we have to skip one element in between. So temp next is equal to temp next next. Okay. Now we can delete the to delete. Yes, we don't need that anymore, and then we can return the head at the very end. Okay, let's see if this solution works. Solution. Oh, there's just some typo here. Okay. One more time. Yeah, lots of spelling mistakes. There you go. So as you can see that all the test cases are passing. So this was basically the very simple and straightforward solution of how we can find the middle node of a linked list. And yeah, thank you so much for watching. And